Have you ever wondered about the mysteries of the universe and the role of exotic matter and antimatter? The cosmic landscape is filled with countless wonders, many of which seem to defy our understanding. Among these, exotic matter and antimatter stand as some of the most captivating and elusive phenomena. These peculiar forms of matter, distinct from the ordinary matter that makes up the world we know, hold keys to perplexing questions about the universe's inception and evolution. There's a universe of difference, quite literally, between the matter we interact with daily and these exotic counterparts. So, what makes them so distinct? What role do they play in the grand cosmic ballet? And why, despite their crucial importance, do they remain so elusive? To unravel these cosmic enigmas, we need to dive into the world of particle physics. An adventure awaits us, a journey where we'll probe the smallest particles to comprehend the cosmos's grandest mysteries. So buckle up, for we're about to embark on this thrilling exploration. In the early universe, just moments after the Big Bang, exotic matter and antimatter played pivotal roles. These weren't ordinary particles, they were extraordinary, exotic even. Now let's imagine the universe as a newborn, a mere fraction of a second old. In this infant universe, temperatures were incredibly high, creating a soup of particles and antiparticles. Among these were our protagonists, exotic matter and antimatter. Created in pairs, each particle of matter had a corresponding antimatter counterpart. When they met, they annihilated each other, releasing energy in the process. But here's the twist. For reasons still not fully understood, there was a slight asymmetry. A tiny bit more matter was formed than antimatter. And it's this surplus of matter that eventually formed galaxies, stars, and everything we see around us today. The interplay between exotic matter and antimatter was key to shaping our universe, but these are not easy particles to study. Despite their elusive nature, studying exotic matter and antimatter is crucial for our understanding of particle physics. Today, researchers worldwide are tirelessly working to probe these enigmatic particles, yet the journey is not without its challenges. The fleeting existence of these particles makes them incredibly difficult to study. They annihilate upon contact with ordinary matter, leaving little traces behind. But why, you may wonder, do we bother with such daunting tasks? The answer lies in the profound implications this research holds. If we can understand the properties of exotic matter and antimatter, we could potentially reveal new laws of physics, provide insights into the early universe, and even challenge our current understanding of reality. The quest for knowledge is often marked with uncertainty and complexity. Yet, it's those very challenges that make the pursuit all the more exciting. As we continue to probe the secrets of the universe, the mysteries of exotic matter and antimatter remain at the forefront of particle physics.